In today's lesson, we're going to look at how to express very large and very small numbers using scientific notation. All right, let's first of all start by talking about how to write numbers in scientific notation. When a number is written in scientific notation, this first number right here is greater than or equal to 1 less than 10. Basically, it's like saying that that number has to be between 1 and 10. And then we're going to express our exponent then as times 10 to the nth power, so whatever power you have then. So let's start first by taking these numbers that are written in scientific notation, and we're going to write them in standard form. When you have a positive exponent, it's like you're multiplying it by 10 that number of times. So for example, in this first one, we have 7.63 times 10 to the 6th power. What that means is that it's being multiplied by 10 6 times. Now every time we multiply a number by 10, we move the decimal place over one place to the right. So I'm going to move it over one place, 1, 2, 3, 4, 5, 6. Now, anything that is after that last number, I do have to have a placeholder for. So we're going to have 763, and then now we have to go and place the 4 zeros that are after that so that we move the decimal place over 6 places to the right. So our new number then is 7,630,000 written in standard form. Now, when you write a number in standard form and you have a negative exponent, that's like you're dividing by 10 that number of times, and you're moving the decimal place to the left. So in this case, we have 1.853 times 10 to the negative 3. Well, what that means is that we're going to move 3 places to the left. And we need to have these zeros as placeholders. Do not forget to put a decimal there, because that value will completely change if you do not have that there. And you could leave it like this. You could put a 0 in front of it. It doesn't matter. What really matters is that you move the decimal 3 places to the left and that you have the decimal right there. All right, so I'd like for you to pause the video, and I would like for you to try these two. Once you're done, resume the video, and then let's take a look at how you did. All right, so for question number 3, hopefully you moved the decimal 5 places to the right, giving you a number, let's see, what would this be? 524,300. And hopefully for number 4, you saw that because we had a negative exponent that we were moving it to the left, and so we had to move the decimal place 4 places to the left, making sure that we've got our decimal point right there. So 0.00090023 would be your answer. All right, so now we're going to write numbers in scientific notation. Remember, our first number has to be greater than or equal to 1 less than 10. And so when we look at this, we need to place the decimal in a place that is going to make that first number greater than or equal to 1 less than 10. So my first number here is going to be a 3.6. And I can drop all the rest of the zeros since they're at the end there. Now, I can look at this 2 different ways. Well, my number started out as a bigger number and I made a smaller number, so I need to compensate with a bigger exponent. Another thing you could do is right off the bat, when you're looking at your number, if the number is greater than 1, it's going to be a positive exponent. If it is that number between 0 and 1, it will end up being a negative exponent. So in this case, what we did is we made it smaller by 1, 2, 3, 4, 5. So we made it smaller by 5, meaning I need to make my exponent bigger by 5. The other thing you could do is you could say, okay, well, I put my decimal right here, and how many places is it going to take to put it back? And it's 1, 2, 3, 4, 5. So 3.6 times 10 to the 5th power is your answer. Now for the second one, notice that our number is starting out between 0 and 1. And so we know that this is going to be a negative exponent. So I'm going to place my exponent, or my decimal, right here. My first number is going to be 6.72 times. Now, I made my new number bigger by 3, so I know that I need to have an exponent that is going to be smaller, or a negative exponent, by 3. The other way to do that is to take the decimal that you just placed and count how many places to put it back. 1, 2, 3. So our answer to this one is 6.72 times 10 to the negative 3 power. All right, so for our next one, I would like for you to do me a favor. If we could make this last number right here, let's make that a 0. So make that 9 into a 0. And so the first thing you're going to do is you're going to start with 84,200 versus that 209. So, and then I would like for you to pause the video now. I'd like you to give these two a try and then resume the video and see how you did. All right, so we have, we placed the decimal between the 8 and the 4. So we have 8.42, and then, and also we noticed that this number was greater than 1. So we knew we had a positive exponent, and it's 1, 2, 3, 4 to put it back. So 8.42 times 10 to the 4th. Now for our next one then, we place the decimal between the 3 and the 2. We noticed that the number was between 0 and 1, so it's a negative exponent. And then 1, 2, 3, 4 to put it back. And so we have 3.21 times 10 to the negative 4 power. All right, and in our next examples, we're going to be multiplying and dividing the scientific notation without a calculator. So this is a standard where you can't use a calculator. So we're going to start by multiplying the 3 times the 2, just like we always have. 3 times 2 is 6. And then we're going to take 10 to the 3rd times 10 to the 4th. Remember, multiplying exponents with the same. Add them together, so we'll have times 10 to the 7th power. And you're all done. Actually, you would maybe want to make sure, once you multiplied, is this still in scientific notation? Yes. My first number is greater than or equal to 1, less than 10, so we're good. Now our next one, number 2, where we're dividing. So again, we're just going to take our 8 divided by 4 and get 2. And then 10 to the 5th divided by 10 to the 3rd, we're going to subtract the exponents and get 10 squared. And since 2 times 10 squared, or 10 to the 2nd power, is in scientific notation, we know that that is our answer. Now for the third example, we're going to again take 15 times 3, 5 times 3 is 15. And now let's multiply these, and we're going to get times 10. We're adding the exponents to the 5th power. Now, hopefully some of you are noticing that this is not in scientific notation, because that first number has to be greater than or equal to 1, less than 10. And so in order to then put this decimal right here, I need to make that so it's greater than or equal to 1, less than 10. I just made our new number smaller by 1. And because I made my new number smaller by 1, I need to increase my exponent by 1. All right, so in our last example, we're going to take a look at two screens from the calculator. And when you multiplied this number by a really big number, it appears that they have the answer, which is 5.2978 E10. Well, what that means is that you have 5.2978 times, well, where you have the e to the 10th power, that means that you have 10 to the 10th power. So if it asked you to write this in scientific notation, that's what you would do. But we're asked to write this in standard notation or standard form. So all we need to do then is to move our decimal place over 10 places to the right. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a pretty big number. So you'd have 5, 2, 9, 7, 8. And then I've got, I believe, 6 zeros here. All right, so there we have our new number. That's a really big number. And notice the reason why the calculator couldn't go out that far, so then it wrote it as an exponent. Whereas for our second example here, I have 5.29e, which then is going to be times 10 to the negative 6 power. Well, if I wanted to write this then in standard form, I would be moving my decimal place 6 places to the left. So 1, 2, 3, 4, 5, 6. And so we're going to have 5 place values for those zeros. 1, 2, 3, 4, 5. And then remember this one is our 6th place that we had moved it. All right, and you can put a 0 at the front if you want to, and there is our new number. So in this lesson, we took a look at how to write numbers in scientific notation and then converting them back into standard form.